You've probably heard a stroke called a brain attack. And you know what? It's a pretty fitting name because that's exactly what it is, a full-on medical emergency where every single second is absolutely critical. Today, we're going to break down exactly what happens when the brain's vital supply lines get cut off in the most common type of stroke. So, first things first, there are really two main kinds of stroke. You've got the hemorrhagic stroke, which is a bleed. Think of a pipe bursting inside the brain. But the one we're going to focus on, the one that's way more common, is the ischemic stroke. That's a blockage. And that's our story for today. What happens when a clog in the system cuts off that precious blood flow? And here's the game plan. We'll start by defining what a brain attack really means. Then we'll take a look at the brain's incredible plumbing system, figure out how it gets clogged up, and see what happens to brain cells when the supply line gets cut. Then, and this is super important, we'll cover how to spot the signs. And finally, we'll talk about the race against time for treatment. All right, let's jump right in. To really get a handle on what's going on, we need to have a super clear definition of what this kind of brain attack actually is. Okay, so at its core, an ischemic stroke is a supply chain crisis. The brain is incredibly hungry. It demands a constant, heavy flow of oxygen and nutrients, all delivered by the blood. When that delivery is suddenly cut off by a blockage, those brain cells are literally starved, and they can start to die within just a few minutes. Now, you might be wondering, what if someone has all the signs of a stroke, but then they just go away? Well, that's something called a transient ischemic attack, or TIA. And please, don't think of it as a mini stroke that you can just brush off. No, this is a massive, flashing neon warning sign that the conditions in the body are primed for a major, life-altering stroke to happen. To really understand what's at stake here, we need to appreciate the intricate and, frankly, brilliant plumbing system that keeps our brain online. It's this network that feeds every single command center we have. Think about it. Every part of the brain has a hyper-specific job. Your frontal lobe handles your decisions. Your temporal lobe is crucial for memory. Your cerebellum keeps you balanced. And this is exactly why stroke symptoms can be so different from person to person. It all comes down to which one of these control centers is being starved of blood. But here's the amazing part. The brain actually has a built-in backup generator. It's an incredible piece of natural engineering called the Circle of Willis. Basically, it's a ring of arteries that connects the main supply lines. So if one of those pathways starts to get narrow, this circle can actually reroute blood flow around the problem area, creating a natural detour to keep brain tissue alive. Pretty cool, right? But even that brilliant backup system can get totally overwhelmed by a sudden massive blockage. So the question is, how do these clogs, these roadblocks, even form in the first place? Well, there are two main ways it can go down. It often starts with this process called atherosclerosis. First, something, say toxins from cigarette smoke, damages the smooth, slick inner wall of an artery. The body responds to this injury by forming a plaque, which is basically a patch made of fat and cholesterol. Now here's the real kicker. That plaque can develop a hard outer shell, and if that shell cracks open, the body thinks it's a wound and rushes to form a blood clot to heal it. The problem is, that helpful clot can become the very thing that blocks the entire artery. And this whole process leads to two kinds of clogs. First, you have a thrombus. That's the clot we just talked about. It forms right there on site in a brain artery. But then you have an embolus, which is a traveler. This is when a piece of a clot breaks off from somewhere else in the body, maybe the heart, travels through the bloodstream, and eventually gets wedged in a smaller artery in the brain. So two different journeys, but the same disastrous destination. Okay, so the clog is now in place. The blood has stopped flowing. Now we're going to zoom way in, down to the microscopic level, to witness the brain under siege, minute by devastating minute. And this brings us to a really critical question. When that blood flow is cut, is the damage just instant and permanent? Is there any hope at all for that affected brain tissue? And the answer, thankfully, is that not all is lost right away. See, around the central core of dead tissue, there's this region called the ischemic penumbra. The cells here are injured, they're failing, but they are not dead yet. This is the battleground. This is the tissue that doctors can save if they restore blood flow fast enough. And that is why time is so important. Because the attack on these cells is just relentless. Within minutes, they're out of fuel, which causes them to swell up with water. Then a flood of calcium unleashes all these destructive molecules inside the cells, tearing them apart from within.
And finally, over the next few hours, inflammation kicks in, leading to even more swelling. And remember, all of this is happening inside the skull, a solid bone box with zero room to expand, putting pressure on everything.
Okay, so we've covered the what and the why. Now we need to pivot to the single most important practical piece of information in this entire explainer: how you can recognize that this is happening to someone right in front of you.
Seriously, if you take away only one thing from our time together today, please make it this word: fast.
FAST is an acronym that makes it easy to spot the signs. F is for facial drooping. Ask the person to give you a big smile. Does one side of their face droop? A is for arm weakness. Ask them to raise both of their arms. Does one of them drift downward? S is for speech difficulty. Is their speech slurred, or are they struggling to find the right words? And T is the most important one: time to call for help. If you see even one of these signs, don't wait. Don't second guess. Call for help immediately. Because that single phone call is what kicks off the incredible race against time. So for our last section, let's look at what happens next from the emergency room all the way to long-term prevention. The first thing doctors need to do is get a picture of the brain using a CT or MRI scan. They need to confirm it's a blockage and pinpoint exactly where it is. From there, the goal is simple: get that blood flowing again as soon as possible. This can be done with powerful clot-busting drugs or even surgical procedures to physically go in and pull the clot out. And then after the crisis, the focus shifts entirely to prevention, managing all those risk factors so this doesn't happen again. Ultimately, it all just boils down to this single, urgent truth. The goal is to reestablish blood flow as quickly as possible to prevent further cell death, particularly in the penumbra. It's all about saving that vulnerable, at-risk tissue we talked about. That is what the entire fight is for. So, we'll end on this thought: the medical response is truly a race against the clock. But the most powerful idea here might be that up to 80% of strokes are preventable. That's a huge number, and it kind of puts the power back in our hands. So it leaves us with a really important question to ask ourselves: what's the one change you could make starting today to protect your own brain's vital supply lines?